Morning, everybody. This is going to be my probably only attempt at the Unit 7 review video. I apologize for the lateness of it, but there we go. So first off, unit circle. This is no notes, no calculator, so make sure you're aware of that. You need to know the degrees, radians, sine, and cosine for everything for highly proficient, and just the first 90 degrees. So the first quadrant, including 0 through 90 degrees for proficient. You're allowed 2 mistakes, but make sure you recognize that if you swap your cosine and your sine, that's 2 mistakes. So what we're going to start with is I'm going to go ahead and put in all the degree measures, and recognizing, of course, just for your own knowledge, that the degrees are in here. We're going to write them out here simply because it's a little bit easier to keep track of everything that way. So everything except for the 45 family goes by 30. So I'm going to fill in all the 30s. I'm going to start with 0, 30, 60, 90. Really, you're just counting by 3s when you do this part. 120, 150, 180, 210, 240, 270, 300, 330, and then full circle to 360. And then the last thing we need to fill in is the 45s. That's halfway between the 30 and the 60 in each quadrant. So we have 45. 120 plus 15 is going to give me 135. 210 plus 15 is going to give me 225. 300 plus 15 is going to give me 315. And then I have all my degrees filled in. Now for the, for the radians, the best way to do this, in my personal opinion, is start by cutting everything in half. So once we cut this in half, all right, maybe that won't work. So when we cut our circle in half, and we know that the full circle is 2 pi. So if we cut that in half, we know half of that is 1 pi. I'm going to try to erase, oh, not that, never mind. And then we cut it in half, wrong color, cut it in half again. So half of 1 is just 1/2. So this is going to be the pi divided by 2. And then as we go around the circle, and this is where the pattern stuff kind of starts, this is starting here 0. I didn't write the 0 in radians. I already have it in degrees. It's good enough. So 0, 1 pi over 2, 2 pi over 2, which is, of course, already reduced. And then this is 3 pi over 2. And then if we full circle, 4 pi over 2, which, of course, reduces to 2 pi. So then I'm going to go ahead and get, whoops, too much. I have to rewrite that, sorry. I get rid of those lines. No, hang on. Oh, I'm going again. I don't know when I paused and when I stopped. Oh well. Sorry about that. I split that in half again with the 45 family. Now I'm splitting the top half of my circle into 4 equal parts. So I have 1, 2, 3, and 4. So the top half is pi, so each of those is going to be 1 pi over 4. Get rid of those. So 1 pi over 4, or just pi over 4. Again, as we go around the circle, 2 pi over 4, already reduced for us. 3 pi over 4. Keep going around. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So, whoops. Having a hard time this morning, sorry. So 5 pi over 4, 6 pi over 4, 7 pi over 4. So then as we go around again, now we're going to split this by the 60-degree family. The thing that you need to be careful with the 60-degree family is recognizing what is and is not a part of that. This line right here is a part of the 60-degree family. So the green lines are now splitting this into 6 equal parts, or if I just look at the top half, 1/3 pi. So as I start around the circle, right here I have 1/3 pi, or pi over 3. Sorry, I'm having to swap things. So pi over 3, 2 pi over 3, 3 pi over 3, already there and reduced, 4 pi over 3, down to the next screen, 5 pi over 3, and then finally, if I come all the way back around, that's 6 pi over 3, which is, of course, 2 pi. The last one encompasses everything except for the 45 family. So 30 degrees also includes my 90 degrees. So we got a lot of things going on here. Nope, not that one. Just kidding. 30 and the 60-degree family as well. So as messy as this is getting, the yellow lines cut that into 12 equal parts, but if you just look at the top, it's cut into 6 equal parts. So we have 1 pi over 6, or 1/6 pi. And then if we just go by every 30 degrees, that's how we have to count the 30. So 1 pi over 6, 2 pi over 6, already reduced, 3 pi over 6, already reduced, 4 pi over 6, 5 pi over 6. So I need to add that one in. 6 pi over 6, 7 pi over 6, 8 pi over 6, already reduced, 9 pi over 6, already reduced, 10 pi over 6, already reduced, and finally 11 pi over 6. And if we do that, all of those in that order, not 3, sorry. Sorry, pushing all the wrong buttons. Okay, back, there we go. 6. If we do it in that order by the time we're finished, the 30-degree family and radians should be done. The last thing I want to talk about is the sine and cosine values. And this all stems from, I'm going to put this on and then I'm going to take it off. Bless it, my goodness. So all this comes from the fact that we have triangles all throughout this that are right triangles. And they help us figure out what the coordinates are right here. Because remember, this is all on a grid. This is a radius of 1. So this point right here is going to be 1, 0. So I'm going to take that triangle off so it doesn't get too confusing. But so off to the side, I've got, obviously not to scale, but a 30, 60, 90 triangle that you learned about in geometry and we talked about in class as well. The short side of the 30, 60, 90 triangle, and I probably should draw that a little bit better because I want you to recognize the short side versus the longer side. The 30, 60, 90 triangle was an equilateral triangle that was cut in half. So with a radius of 1, that gives us a hypotenuse of 1, which means the short side is 1/2. And when you do the Pythagorean theorem and rationalize your denominator, the third side is rad 3 over 2. Not 3. Apparently I'm having trouble with that today. And then the 45-degree family, if we have 45, 45, 90 triangles, those are isosceles triangles with 2 equal angles and 2 equal sides. If my hypotenuse is 1, then both of my sides are rad 2 over 2. And that 45, 45, 90 triangle, that would go in right here. And this side right here gives us our x value, tells us how much to go over, and then how much to go up. tells us this value right here. So when we're looking at this all ends up, let's go back to the 30, 60, 90. The sine is the opposite over the hypotenuse. So it's always going to be this long side or the short side because the hypotenuse is always 1. So it's always just the value of the short side on the unit circle. So our y value, how much you go up, is the sine. And the cosine is the adjacent side over the hypotenuse. So it's always going to be the x value. So that's important to note, that your cosine is x and that your sine value is y. So I guess I'll go ahead and leave that triangle there because if I erase it, everything's going to get all screwy. So as I go around this, the 30 degrees, this is going to be over the long side of this triangle. So this is rad 3 over 2, and this is 1/2. And then I can reflect that over the y-axis to the second quadrant and make the x value negative rad 3 over 2 and positive 1/2. If I reflect that again over the x-axis, I have negative rad 3 or square root of 3 over 2, and then negative 1/2. And then I reflect it one more time to be positive square root of 3 over 2 and negative 1/2. And then I do the same thing with my other ones. The 45 family, both are going to be square root of 2 over 2, or rad 2 over 2. And again, we just have to make sure we know which ones are negative. So all of this, like so many things in math, it's all about understanding the pattern. And if you understand the pattern, the full circle is really not difficult to get. If you try to just memorize it, that's a different story. It gets much easier to make small mistakes, or a lot of small mistakes, if you're not thinking about the pattern, if you're just trying to memorize the numbers. All right, our last one are 60 degrees. Now, this right here, the x value is the short side, so that part's 1/2, and then this is going to be the rad 3 over 2 because the 30, 60, 90 triangle is the same as the 60, 30, 90 triangle. So that's going to be 1/2 square root of 3 over 2. And the reason I brought up the triangles rather than just go around the circle is that a really common mistake when people do this is they get these two mixed up. And if you recognize the triangle and can tell which side is the short side, then you know that's going to be your 1/2. So again, reflect over the y-axis, negative 1/2 rad 3 over 2, negative 1/2, negative rad 3 over 2, and make sure those negatives stay outside of the square root sign. 1/2, negative rad 3 over 2. Then we're almost done. The only thing not on here was already on the original unit circle that I gave you. But our coordinates out here on my x and y axes may seem fairly obvious to some people, and other people just don't quite catch it. Remember, our radius is 1. So this distance from here to here is 1. That makes this point 1, 0. Up at the 90 degrees, that is 0, 1. And negative 1, 0, and 0, negative 1. And that's the unit circle. And I know it seems like a lot, but again, if you can make sure you understand those patterns, that's going to be best for you. I would highly recommend that you go through and attempt to do a few on your own without your notes. I really would not recommend that you just sit and stare at a unit circle unless you're going through the patterns of the 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, so on and so forth. Recognize which families are which. And of course, on the test, you are certainly allowed, and I would encourage you to use any of the color coding that you need to help you discern the different families so that when you are doing the coordinates, it's really easy for you to find where that's going to be over here and over here and over here. Those colors can really help you keep track of everything. Back really quick. are that the cosine is x and the sine is y, and you can also have written on there that the tangent is equal to the sine, I should put theta there, sine over cosine. And then if you really want to, you can go around the side and put the tangent out here, so you already know those in advance. That is your decision, but that's all you can add to the unit circle. Moving on, the next part is just finding the sine, cosine, and tangent. You're going to be allowed your unit circle on this. Make sure that your unit circle is complete, that it's correct, and make sure that it's on its own page. If it's glued into your notebook, that's fine, but make sure there's nothing else around it. The things that you are allowed to have, that you use on the test anyway. As I was saying, we are going to be using the unit circle for this. I'll shrink it down and move it around as we go. The first one, cosine 11 pi over 6. You're going to find 11 pi over 6 on your unit circle. So right here, cosine is the x value, so this rad 3 over 2 is our answer. Make sure that you read through all these little parts. I should point to what I'm talking about. What's expected for the proficiency value, find those sine, cosine, and tangent values for either degree or radian measures. You don't need to change that. That's not a conversion thing. That's just finding the sine or cosine. And then for the proficiency level, that'll all be between 0 and 360 or 2 pi. For highly proficient, you need to find negative values. So that's if you're starting here and you're going around the circle this way instead. And then also ones that would be greater than 2 pi, so meaning you have to go around the circle more than once. So an example for that one, like the negative, we'll look at number 5. Negative pi, sine of negative pi over 3. The regular pi over 3 is right up here. Negative pi over 3 is going to be directly below it. I'm just going in the opposite direction. The sine value is my y value, so that's going to be negative rad 3 over 2. Whoops. If I look at the tangent, now I'm looking at number 7. If I look at the tangent of negative pi over 6, so instead, keep using the wrong function, sorry. So pi over 6 is right here. Negative pi over 6 is going to be right here. Tangent is the sine over the cosine. I just pointed the wrong direction. Sine over cosine, so 1/2 over, and that's a negative 1/2, over square root of 3 over 2. Remember, anytime you divide by a fraction, that's the same as multiplying by the reciprocal. So this is the same as negative 1/2 times 2 over square root of 3. The 2's are going to divide out. So I'm left with negative 1 over the square root of 3, which is fine for proficiency. But if you are going for highly proficient, you need to have all of your denominators rationalized, meaning you don't have a square root sign in the denominator. So I can't just square this. A lot of people want to do that, but that changes the value of it. So I can multiply it by 1 without changing the value of it. So I'm going to multiply this by the square root of 3 over the square root of 3, because anything divided by itself is just 1. So then top is going to be negative square root of 3. The bottom, square root of 3 times square root of 3 is just 3. So that's my tangent value at negative pi over 6. So that's just a couple of examples of that section. Hopefully that helps. Again, you can use your unit circle and nothing else on this part. I suggest you double check a few times and make sure your unit circle is complete and correct, and that's not what I meant to do. But all good to go. The third section is going to be in 2 parts. One's going to be the transformations, A, H, and K. That is 7-4 that we worked on. Part B is just going to be the period change, and for proficiency, the period change will just be the period change and nothing else. Highly proficient is going to be particularly difficult with up to 5 transformations, so a change in A, H, and K, maybe a negative A, and then a B value as well. So that one's going to be significantly more difficult. So I'm going to go ahead and do number 4 on this one. Since it's the most difficult, we've got a few different things going on here. The first thing I need to do is my scale. So I'm going to do pi over 2, pi, 3 pi over 2, 2 pi. I'm going to go ahead and extend this out. 5 pi over 2, and 3 pi. The next thing I need to figure out is what my highest and lowest points need to be. And I do that by taking my midline, which is -2, adding my amplitude, and subtracting my amplitude. I'm going to ignore the negative for right now because in either direction it's going to go up and down 3. So -2 plus 3 is going to give me a +1, and -2 minus 3 is going to give me a -5. So I need to go up to -1, and I need to go down 1, 2, 3, 4, 5. So -5, -4. Okay, so I'm going to draw on my midline at -2. And I'm going to draw in my horizontal starting point, which is pi over 2. Remember, it's x minus h, so an x minus will move it right, and x plus will move it left. And then I'm going to look at my amplitude. I'm going up and down 3, but I also have a negative, which means the normal cosine will start above the midline, go down to the midline, go back up. But the negative cosine is going to start down instead. So the points I need to have, my first point is going to be here at -5. Going to come up to the midline, up to +1, back to the midline, and back down. Remember, those 5 points, when we do those transformations, all need to be very clearly marked. So that's going to be my negative cosine graph on that one. So again, just an example of it, and let you do the rest of them yourself. The period change, number 5, specifies a negative sine equation. Something like this, you're going to want to specify what your starting and ending point is. The first thing to figure out, though, is where your midline is. It's going to be halfway between the top and the bottom. So if I need this to be a sine graph, I'm looking for a place that it starts on the where it's actually at the midline. So I have those 4 spots where it's actually at the midline. A negative sine graph means it's going to be going down first. So what I really need is that one right there. That's there can be other ones. There's infinite ways to write equations for these because of the cyclical nature of them. So here it's very, very hard to read this, but right here is -pi over 2. So that's going to be my horizontal starting point. My K value is at 1 because I moved my midline up to 1. My amplitude is 3. This is starting at -pi over 2 and it's ending at 3 pi over 2. So this is a regular period, no period change on this one. And because it's a negative sign, because it goes down first instead of up first, then this is going to be, the equation would be -3, because that's my amplitude and it's going down, and then sine x plus pi over 2, and then +1. So that's my negative sine graph for that one. Graphing the equation on number 6, this value right here, that gives us a, a period change. So it tells us that, I know that the period length is found by 2 pi over b, so 2 pi over 2, those divide out. So my period length is pi. That means I'm going to finish this, midline up, midline down, midline. I'm going to finish one of those cycles within pi instead of the regular length of 2 pi. This minus pi means I'm going to move this over, so this is my vertical starting point. Not vertical, sorry, horizontal starting point. My midline stays at 0. There's been no change in k. And there's been no change in the amplitude either. So I'm going to start here, and I'm going to end here. So that means it's going to cross back to the middle point, and now I have to make use of the space in between to do my up and down. So that's that one right there. Lastly, we have our degree and radian conversion. You'll be allowed a basic calculator on this, and I'll provide those. No unit circle. You do need to be able to use the formulas. So the degrees, if you want to convert to degrees equals the radians over 2 pi. That gives us the fraction of the circumference of the circle, and then we multiply that by 360. The easier conversion, or the simplification of that, is the radian times 180 over pi. Because a lot of times the radians are in fractions, so it's a little easier to have that kind of standing on its own. I would make sure you have that on your stamp sheet. You will be allowed to use your stamp sheet for that one. On the flip side, radians, if you're converting to radians, that's the degrees out of 360. That gives you the fraction of the circle that you're dealing with. And then we multiply that by the full circumference of 2 pi. Again, the simplification of that is the degrees times pi over 180. And main thing here is you just reduce the fraction when you're done. The reason you need to be able to use the formula is a lot of these you may know, like pi over 2 and 45 degrees, and a lot of those you may know, but pi over 8, that's not what it's on the unit circle, obviously, but it's not a space we've been using on the unit circle. 35 degrees, 20 degrees, so you need to be able to do those and then reduce your fraction. That's about all I have time to do. Hopefully that helps you prepare for your test. Make sure that you're reading all of these headings carefully so that you know what you're allowed to use and so on and so forth. And that's it. Have a great day.